Hi everyone, my name is Luigi Dovesi and I'm a deep learning engineer at Universus. Today I'm presenting the work Real-Time Semantic Stereo Matching. This work was done as a collaboration between Universus, KTH and the University of Bologna. Here we are focusing on mobile robotics. To develop a fully autonomous system able to navigate in an unknown environment, scene understanding is essential. Indeed, before performing high-level reasoning such as path planning or collision avoidance, an intelligent agent needs to recognize objects in its surroundings and determine their 3D location. This kind of knowledge implies two parallel understanding capabilities, semantic and geometric. These two tasks usually consist of semantic segmentation and depth prediction. Moreover, a mobile robot presents additional challenges. First, the perception has to occur in real time and with good accuracy so that the understanding could always be timely and relevant. Second, mobile robots have very low computational capabilities. Third, the perception should dynamically adapt to the robot needs as a trade-off between accuracy and speed. For example, when a robot is moving at high speed, we can sacrifice accuracy in favor of high output rate to ensure safety and responsiveness. On the other hand, when approaching other objects or complicated scenarios, we might want to dynamically switch to high perception accuracy at the cost of inference time to gain better understanding of the surroundings. In this work, we will try to address all the aforementioned shortcomings by proposing the first real-time method to tackle seamlessly stereo matching and semantic segmentation. The task of real-time stereo matching has been addressed by several methods already. Among them, AnyNet obtain impressive speed while allowing dynamic runtime early stopping. The low accuracy, anyway, might represent a bounding limitation for several use cases. Similarly, there exist approaches aimed at multitask stereo matching and semantic understanding. The work SegStereo is jointly learning depth and semantic segmentation and obtain state-of-art accuracy. Nonetheless, these methods are lagging far behind the real-time performance required by most practical applications. To reach these goals, we propose a novel real-time semantic stereo network. The network is divided into four distinct modules: a shared encoder, represented in blue, a stereo disparity decoder, in yellow, and a semantic decoder, in green. Finally, in purple, we find a disparity refinement module. Our network design consists of a fully residual pyramidal architecture. This allows achieving high accuracy with limited execution time. The network is designed to keep a symmetrical architecture between disparity regression and semantic segmentation, so to facilitate the exploitation of the shared parameters. Both segmentation and disparity are fully computed only at the lowest resolution and progressively refined through the higher resolution residual stages. The same design occurs for the final refinement module. To achieve this, we perform a cascade of residual concatenations between semantic class probabilities and disparity volumes. This fully residual setup provides consistent advantages both at training time, because of better stability, and especially at testing time, since we can dynamically adjust the speed-accuracy trade-off. We extensively evaluate the performance of our network in terms of both accuracy and runtime. To compare different variables of our model and measure the impact of each design choices, we report quantitative results on a validation split sampled from Kitty 2015. Here we collect the outcome of these experiments conducted on both AnyNet and our proposal. At all stages, at the cost of a lower frame rate, our method allows for a significant improvement on disparity estimation, as well as to obtain good results in semantic segmentation. It's interesting to observe that the margin between disparity metrics gets larger by increasing the number of features. This highlights that increasing the number of features is much more beneficial for the multitask model rather than the single task approach. Here we measure the contribution given by both the multitask learning paradigm and the synergy refinement module specifically designed for our network. In the first row, we present the results of the variant made of the shared encoder and the disparity subnetwork only. Then, we can notice how, by simply adding the semantic network and train for joint optimization of the two tasks, we slightly increase the disparity accuracy. This result is not trivial, since it implies that there is no compromise between the two tasks. But instead, our architecture can exploit their synergies. Finally, we evaluate the impact of the synergy refinement module. As expected, it leads to a consistent disparity estimation improvement. Our network allows for trading accuracy for speed by runtime early stopping. Here we compare the trade-off achieved respectively by Anynet and our architecture measured on the NVIDIA Jetson TX2. We can notice how our network at any stage runs roughly at half the frame per second with respect to Anynet, while achieving large accuracy improvements. Moreover, we highlight a comparison between the second stage of our network and the final stage of Anynet. Here, we can observe how the proposed architecture is both faster and more accurate than the last stage of Anynet, while seamlessly providing good quality semantic segmentation masks. Finally, we present our results on the Kitty 2015 online benchmark. Here, we can notice how our results are more accurate than previous real-time frameworks. This confirms the effectiveness of jointly inferring semantic and disparity estimation. The gap with accuracy state-of-art architectures is reported in the upper portion of the table, and it ranges between 1.2 and 1.7%. Yet, we run 7 to 90 times faster. We also submitted our results in the Kitty Semantic Segmentation Leaderboard. By using an NVIDIA 2080 Ti, when regressing only semantic information, our network inference takes only 8 milliseconds, while instead considering depth plus semantic, it takes 20 milliseconds. Compared to seg stereo, our network performs slightly worse on class level, while being more accurate on categories and running about 30 times faster. We also outperform some competitors specifically trained for semantic segmentation only. In conclusion, this paper proposes a fast and multi-stage end-to-end network for stereo matching and semantic segmentation. We exploit the synergies between the two tasks, both with parameter sharing and with a final fusion module. To the best of our knowledge, our proposal is the first network enabling to simultaneously infer both tasks together with high accuracy and in real time, even on low-power devices. Following, we present qualitative results on an unseen Kitty sequence.